Greetings and salutations to my geometry wonderkin. I just made all that up on the fly. All right, welcome. Glad you are hopefully at school right now listening to me, or you're watching it at home, or you're having trouble falling asleep at night, so you pulled this up to watch because you know it'll put you to sleep in no time whatsoever. As I thought about how I wanted to start, I was going to just do the usual, and tell you a joke, but instead I thought I would share with you one of my most embarrassing moments in my life. So I was a sophomore in high school, which you are right now, Athena, isn't that correct?
Mm-hmm.
I was your age, and I thought I was fully in love with the captain of the high school cheerleading team at our high school. And I wanted her to know how much I felt about her, even though we really had no relationship. We weren't even, as you all say, talking. I had talked to her, but that's a different thing. Anyway, so I had this brilliant idea. You all have probably heard of Lionel Richie. He's a singer. Some of you probably mostly know him as a judge from American Idol, but back in the day, he put together some amazing love songs, including a love song called Hello. Hello, is it me you're looking for? Anyway, I'm not going to sing it. I'm sure most of you or many of you know it. I loved the song. So I had the greatest idea. I pulled out a pen and a piece of paper and decided to write her a letter. And so I said in the letter, "Dear Lisa," that's her actual name, I said, "I am writing to you because I feel like I want to tell you something. I'm not quite sure how to tell you, but instead I thought the words of this song would tell you much more than I could ever express." And so I literally wrote down the words to the song Hello, which the line is, "Hello, is it me you're looking for? I wonder where you are, I wonder what to say." Anyway, what I want to say so much is I love you. And I sealed it up and mailed it to her and thought, oh, how could this possibly go wrong? And I was soon to find out, because the next thing I heard in a couple of days when she had received the letter was she opened it up, thought it was hilarious, and showed it to all of her cheerleading teammates, and they all got a big kick out of it. And I was fully embarrassed. More importantly, I learned a very valuable lesson. Never write things down because they can come back to bite you in the backside later. So, thought you'd enjoy that, one of my more embarrassing moments. All right, that being said, on to reality. Yay! What I wanted to do here is go over the homework that I have assigned for you. I technically, at this actual moment, haven't assigned it, but I'm about to, for covering tangents. We will have covered tangents on Friday last week. And with the homework assigned, I wanted to now review the homework very briefly with you. It's not very challenging. I think you all will be fine. With that being said, let's go ahead and get into it. I did not look at the page number again like I should have. All right, let's see that first.
Wait.
Page 491. We're going to start with, as usual, I'm actually going to assign you guys, I think, all. So, sorry. So, 3, 4, 5, and 6. I don't think I'm going to do all of them. I'm going to just do 2 in each section because you'll get the general idea and you can go from there. You are going to need a calculator for these, okay? And as the instructions say, find the tangents of the acute angles in the right triangle. Write each answer as a fraction and as a decimal rounded to 4 decimal places. So I'm going to do problems. Do I want to do? Oh, although they both have it, that's fine. Let's do problem 3 and problem 5. Let's make it easy. All right, so the acute angles, of course, are angle S and angle R. So remember, tangent equals opposite over adjacent. Okay, so we'll start with angle R. Tangent of angle R equals opposite 45 over adjacent 28. Okay? As a fraction, this is the answer. It cannot be reduced any further. As a decimal, 45 divided by 28 equals, I'm writing out to 4 decimal places, 1.6071. 45 divided by 28. Couldn't be much easier, right? Tangent of S is here. It's going to be opposite. It's going to be basically the exact opposite of this. 28 over 45. Again, this is fully reduced as a fraction. As a decimal, it is 0.6, and then the 2's repeat, so we just go to the fourth 2. Okay? Tangent of R, 1.6071. Tangent of S, 0.62222. All right. Dang it, I should have paused there for those of you that want to take a picture of the screen. Sorry. You can rewind. You can watch it later at home if you want at YouTube. All right. Number 5. Our two acute angles are G and H. Tangent of G. Opposite is 2. Adjacent is 1. They just call that 2. And the decimal is also 2. Isn't that easy? Okay? Tangent of H is just the opposite, 1 over 2, which is also 0.5. Okay, that one is really, really easy. I did want you to take a notice at number 4. I'm not actually going to have you do number 4 with me now. I just am curious if you can tell me anything about number 4. Don't actually tell me because I'm not hearing you right now. However, I'm hoping it came to your mind when you saw it and you went, hey, that's a Pythagorean triple, a 7, 24, 25. Yes, it is. Good job. If you notice that, great. Keep it up. All right. Let me slide down to the next section. I am doing these on the fly, if I'm being honest with you. I haven't looked at these at all. What could possibly go wrong? I agree with you. Nothing. All right. Let's look. What do I want to do here? I feel like I want to do number 8 and 9. Okay, we'll do 8 and 9. So now we're finding the value of x. So what's different from this? The first one, it gave us the 2 sides, and we found the decimal. For this one, instead, we're given the angle, and one side, it wants us to find the length of the other side. Okay, not hard, but you definitely need your calculator with the tangential function for this, or the sheet that I handed out to you that has the little cheat diagram that you can also utilize. I'm going to use the calculator. So, the value of x is here, so we're going to do the tangent of 27 degrees. That equals the opposite, x, over the adjacent, which is 15. I'm going to rewrite this equation by multiplying by 15 on both sides, of course. So 15 times the tangent of 27. So in my calculator, 27, hit the tangent button, C, times by 15. And the answer, we're going to round it again to, it says to the nearest tenth. The answer is 7.6. So this other leg is approximately 7.6. Not tough. All right. And I said we'll do number 8. So again, we have, let me see if that's what I want to do. Yeah, it is. So here, just notice the difference. Obviously the difference is the angle is different, but also notice the unknown in number 8 was the opposite leg. The unknown, I'm just going to do it number 10, make it easier because I'm over here. I don't want to walk all the way over there. All right, in number 10, notice the opposite is given. It's the adjacent we're solving for. So that's the only difference. So, tangent of 37, not tam. Tan is something I never am. Okay, tangent of 37 equals opposite 6 over the adjacent, which is the unknown. Now we need to do a little bit of finagling to get x by itself. We're going to multiply by x on both sides, divide by 6 on both sides. So it will be rewritten like this. X equals 6 divided by the tangent of 37. Let me pause and make sure I'm telling you right. Yes, that is correct. All right. So again, with my calculator, as I showed you how to do the other day, I'm going to do this first. Yeah, you know what? I'm gonna experiment right now. Let me just see. Let's see if my calculator is smart enough to just
Play your
do it.
phone.
Tangent equals. Maybe it is. I got, when rounded to the nearest tenth, 8.0. Let me do it the other way just to make sure that that's correct. 37, tangent, memory plus clear. 6 divided by my memory, which is bad. Yes, good. Oh, okay, it works both ways. All right, so at the end of the day, here's your answer. Okay, so the length of the adjacent side is 8. Here is your bonus question. What is the value of the hypotenuse in this particular problem? You know what I'm going to do right now? I'm going to test Athena behind the camera. Athena, what is the value of the hypotenuse here?
For which one? 10? I honestly wasn't really paying attention, so.
I know, but you're so smart.
I don't.
Think very simple. A calculator is not needed.
Is it, I don't know. Oh, wait. Do you, like multiply?
Here's my
No?
hint.
Oh.
Wait, do I need, I'm sorry, what is your name in the
I
back?
forgot. I'm sorry.
Is it, what is your, is it Koa?
It's Melanie.
Figueroa, I knew it was an O. All right, Melody, do you know the answer? What's the value in this one? What's the value of the hypotenuse?
He's asking what the hypotenuse is.
A squared plus B squared equals C squared.
Don't overthink it. Nope, don't go that route. It's a 6, it's an 8.
48.
My hint for both of you is this is a Pythagorean triple.
I
Which
forgot what that.
Pythagorean triple
I
is
haven't
it?
looked at my geometry notes in a while.
I bet you all know it.
Please say you know
It is a, yeah, tell me you know it. Yes, of course you do. Even Brandon. Oh, where to go? All right, hold on. Good.
I don't think Brandon knows it.
Oh, that's so not right, Athena.
I'm kidding. I'm
You're
kidding.
probably true. All right.
Oh.
It is a 3-4-5 triple. A 3-4-5 triple.
What does that mean?
Notice that if you divide 6 by 2, it gives you a 3. If you divide 8 by 2, it gives you a 4. So this is a 3-4-5 triple. The ratio over here is a 5, which means the length of this hypotenuse is 10. Okay? That's the kind of thing why we go over triples. So when you see something like this on an SAT question, for example, you aren't going, oh my gosh, I've got to do the Pythagorean theorem and take forever. Instead you go, oh, that's a 3-4-5 multiplied by 2, it's 10. Yay! All right, great. So happy we had that.
Mm.
All right, goodbye. No, not you, don't turn it off yet, sorry.
I'm not.
I was saying goodbye to what I wrote. Okay. Now, let me see where we're going to next. Probably slide it over, yep, to the upper part. Haven't looked at it yet. Use a special right triangle. Isn't that special? To find
Oh.
the tangent of a given measure, angle measure. So, we're going to do both of these, number 13 and number 14. If it says the given angle measure is a 45 degree, Athena, I get to quiz you again.
Oh my
What special
God.
right triangle is that has a 45 degree in it? Do you recall?
This sounds really familiar.
I know. See what happens to all
Is it-
geometry students? You get into algebra 2 and you forget all of the lovely stuff you learned in geometry.
Pretty much.
All my geometry students would go, oh, that's a 1 square root of 2.
I was gonna say something completely different.
Right? That's a 1 square root of 2 triangle. It's an isosceles right triangle. 45 and 45. We know they're in relationship 1 square root of 2. So the tangent of a 45 degree angle of an isosceles right triangle. Tangent equals opposite over adjacent. Opposite is 1. Adjacent is 1. The answer is 1. Very simple. Okay? The tangent of both angles, obviously, both 45 degree angles. So the tangent of both acute angles of an isosceles right triangle is 1. Number 14 says 30. I won't ask you.
Thank
Athena.
you.
You're welcome. You all should be triggered in your memory to go, oh, that's a 30, 60, 90 triangle. Right? 30, 60, 90. And you are, I'm sure, quite confident that you recall that ratio, 1 square root of 3 to 2. So, tangent of a 30-degree angle. Tangent of 30, I should have wrote tangent of 45 up here. All right, tangent of 30 equals opposite, 1, over adjacent, square root of 3. Okay, we're going to punch that up in our handy-dandy calculators. 1 divided by 3 square root equals, it doesn't tell us when it's not given and we're working with tangents, trigonometry functions. We're going to round it to 4 decimal places. So, what is this thing? All right, 0.5774. Okay, so tangent of 30 is 0.5774. I'll pause for a moment if you want to snap a photo of this amazing work that I've done. I'm hoping for 1 million subscribers because then I can retire. That'd be fantastic. Subscribe now, young people. All right. You know, maybe I'll just record myself teaching and do it enough that I'll just put it all on YouTube and then sell it, and I can just sit at home on.
Do it.
Wouldn't that be great? What a great plan. All right. But then you wouldn't have the joy of being around me in a personal way. So, you know, we're going to do, I haven't even looked at it, but it looks great. Number 15. Okay, this is the Washington Monument. Where is the Washington Monument located, Athena?
DC.
Washington, D.C. Have you been there?
Yeah.
Have you been up inside the Washington Monument?
No.
Okay. It's actually really, really cool. Anyway, Washington, D.C. A surveyor standing 118 feet from the base. Please draw what you need to know. So I'm going to draw, he's out here somewhere, 118 feet. The surveyor measures the angle of elevation from the ground to the top of the monument. Okay? This is 118 feet. This angle is 78 degrees. Find the height of the Washington Monument to the nearest foot. What I like about this problem is this is going to demonstrate the practicality of the tangent formula for how you can solve real-life problems. If you can determine angle of elevation by how the sun breaks over an object that's tall, you can then calculate the height of it. Okay? So, Athena's yawning. I'm boring her to
No, I'm
tears.
sorry.
If she's yawning, that means some of you are falling asleep. Chris, wake up. Oh wait, Chris, that's right, you're with me. All right, I'll make sure you're awake. Okay, so we're going to use tangent. Tangent of 78 equals opposite. That's what we're solving for. Over our distance away from the monument, 118. We're going to multiply by 118 on both sides. Hold on. 118 on both sides. So we have 118 times the tangent of 78 degrees equals ding, 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 dong, boing. All right. That tells us what to round it to the nearest foot, 555 feet. I need, you know what, okay, so that's the answer I got. I need to Google that and see if that's actually reality. Let me see. Wait. Hey Siri, how tall is the Washington Monument?
The Washington Monument is 555 feet tall.
Wow. Wait, maybe you didn't hear that. Hey Siri, how tall is the Washington Monument?
The Washington Monument is 555 feet tall.
Pretty exact.
Hey, look at that. They went with reality. Isn't that great? So who needs, here's the thing that proves, who needs tangents when I have Google? Why do I have to do calculations? I can just ask Google to give me the answers. Sadly, that's reality too, right? Okay, so there you have it. Let me see if there's anything else I want you to do before I wrap up this lesson. I'm sure you're all dying. No, please, nothing else. But you know what? Tough luck.
Do all of them.
Athena wants me to do all of them. That's not very nice. I like the way, I'll do, this will be our last one, I promise. We're going to do 17. You know what I know for sure? I'm doing this because have already assigned this homework with the intention that you would have had done coming into today's class. But you know what I know? Probably at least half of you or more haven't got it done yet. So we're going to do number 17, and I'm going to ask the instructor, Ms. Fuentes or whoever it is, to please pause at this moment to give the rest of you slackers time to do this problem. Go ahead. Great, now we're back. So let's now work the solution. Not that you need it, you already got it now. Again, you should have recognized side lengths of 5, 12, and 13. It should have been dinging in your brain. That is a Pythagorean triple. If not, you're going to do terrible on the test. All right, but I'm sure it did and you're fine. All right, 5, 12, 13. It says, find the tangent of the smaller acute angle in a right triangle. Hopefully you can tell the smallest acute angle is opposite the smallest side. The smallest side is 5, so this is the smallest acute angle. We want to find the tangent of that angle. Tangent equals opposite, 5, over adjacent, 12, 5/12. I feel like I should know that. No, I shouldn't have known that. All right, 0.4167. Okay, so the tangent of the smaller acute angle of the 5, 12, 13 triple is 0.4167. And there you have it. That's your homework for the day. I've given you a practice sheet to work on so that the next time we're together, you'll be ready to get quizzed on these things. Okay? Have a great rest of the day.